Are you a current college student about to start your computer science degree or thinking about graduate school? Then you've probably wondered, what do computer science students actually learn? In this video, we are counting down the 10 most important computer science courses that every CS major takes. Let's get started. Course number 1, Programming Fundamentals. Imagine waking up tomorrow and being able to tell your computer exactly what to do. Build a game, automate your homework, even create the next app. Sounds impossible? It's not. It all starts with one skill: programming. Programming is a way to tell computer exactly what to do. Just like humans speak English, computers understand programming languages like Python and JavaScript. Almost every program ever created is built using three powerful ideas: variables, loops, and functions. Variables are the memory of your program, storing information like x equals 10. Loops are the engine that repeats tasks without making you write the same code again and again. And functions are the building blocks that organize your code into reusable commands. Some of the most common programming concepts are if else statements, loops like while and for, variables, and functions. These building blocks allow programs to make decisions, repeat tasks, store information, and organize code. It's not magic, it's logic. Course number 2, Data Structure and Algorithms. Google searches billions of web pages in less than a second. Netflix recommends movies instantly. How? It's not because computers are fast. It's because they use smart algorithms. Data structures and algorithms teach you how we organize information and solve problems efficiently. Think of organizing information like arranging objects in the real world. An array is like a straight line of books on a shelf. Each item has a specific position, making it easy to access things quickly. A tree is like a family tree or the branches of an actual tree. Information starts from one main point and grows into different levels of connections. These simple ideas help computers organize massive amounts of data efficiently and power everything from search engines to file systems. Sorting, searching and optimizing. Power Google search and Netflix recommendations. Course number 3, Database Systems. Every time you log into Instagram, order food, or shop online, somewhere there's a database remembering everything. But how? Databases store massive amounts of data safely. Think of a relational database like a collection of connected spreadsheets. Each table stores a specific type of information. Rows represent individual records, and columns describe their details. By linking tables together through relationships, computers can quickly store, find, and manage huge amounts of data. Database remember who you are when you log into social media, order food, or shop online. Course number 4, Computer Networks. When you send a message to someone on the other side of the world, it arrives in seconds. But have you ever wondered where it actually travels? It's how computers talk to each other. The client-server model is how most of the internet works. Your device is the client, making requests like opening a website or watching a video. The server receives those requests, processes the information, and sends the response back. Click a button, send a request, receive the result, get a response. IP finds the destination, like an address. TCP makes sure the data arrives safely. HTTP lets your browser and server communicate. Together, they power the internet. What happens when you click send? When you click send, your device converts the message into small data packets. These packets travel across the network using IP to find the destination and TCP to make sure they arrive correctly. The server receives the data, processes it, and sends the message to the receiver, all within milliseconds. Course number 5, Operating Systems. Your computer is running dozens, maybe hundreds, of programs right now, yet nothing crashes. How does it keep everything under control? They are the manager of your hardware. An operating system acts as a bridge between hardware and software. At the bottom is the hardware, CPU, memory, and storage. Above that is the kernel, the core of the OS that manages resources. Next are system services that handle tasks like files, networking, and security. At the top are applications that users interact with every day. The OS stack connects your apps to the hardware, making everything work together smoothly. Processes, threads, memory, management. Keeps everything from crashing. Course number 6, Software Engineering. Writing code is easy. Writing code that thousands of people can use without breaking. That's software engineering. It is the process of building software that scales and lasts. Version control is like a time machine for code. It tracks every change, allowing developers to save versions, undo mistakes, and work together without overriding each other's work. Branching allows developers to create separate copies of a project to experiment with the new features. Once the changes are ready, they can be merged back into the main project. Tools like Git make teamwork easier by helping developers track, share, and manage code safely. Testing, CI/CD pipeline. Design patterns are an important part of software engineering. Great software is engineered, not just written. Course number 7, Web Development. Everything you see on YouTube, Amazon, or Netflix started as lines of code. The question is, could you build something like that? It is the process of building what users see and interact with. A website is built using 3 core technologies: HTML, CSS, and JavaScript. HTML is the structure. It creates the content and elements of a web page, like headings, images, and buttons. CSS is the design. It controls colors, layouts, animations, and the overall appearance. JavaScript is the behavior. It makes websites interactive by adding logic, actions, and dynamic features. React, Node.js, APIs, and databases is how modern websites come alive. Course number 8, Computer Architecture. Your computer performs billions of calculations every second, but what actually happens when you press a key? This is what happens inside the silicon. Every action your computer performs follows a simple cycle called the CPU instruction cycle. First, the CPU fetches an instruction from memory. Next, it decodes the instruction to understand what needs to be done. Finally, it executes the instruction and produces a result. This cycle happens billions of times per second, allowing your computer to run programs, open apps, and perform tasks. CPU, RAM, cache, bus. Opening the hood of the machine. Course number 9, Artificial Intelligence. Chatbots, image generators. They all seem intelligent, but are they actually thinking? They are machines that learn from data. A neural network learns by passing information through 3 layers. The input layer receives the data, such as an image or a sentence. The hidden layers analyze patterns and extract important features. Finally, the output layer produces the prediction or answer, like recognizing a cat or translating a sentence. Training data, weights, prediction. AI isn't fiction, it's math and software. Course number 10, Cybersecurity. Every day, millions of hackers attempt to steal passwords, money, and personal information. The only thing standing between them and your data is cybersecurity. Are the process of protecting systems from malicious attacks. Encryption turns readable information into unreadable code to keep it secure. It starts with plain text, like the message hello. An encryption key is then used to scramble the message into ciphertext. Only someone with the correct key can decrypt it back into the original message. Encryption, authentication, pen testing. Supports functional and secure software. 10 courses, 1 massive field. Master the basics first. Start building today. In this video, we explore computer science courses and learning paths. Whether you are planning to start college, preparing for graduate school, or considering a future in research, this guide will help you understand the different areas of computer science and choose the right direction for your goals. We look at important courses to consider and how different areas of study can shape your academic and career journey. Whether you're a beginner or looking to specialize, this video will help you navigate your options and make informed decisions. Start exploring the possibilities of computer science and find the path that matches your interests and ambitions.